Okay, so if you're building anything with LLMs, you've definitely heard the names LMCache and MemGPT thrown around. And you've probably noticed they both talk about memory. But here's the thing, and this is the key secret. They are not competitors. Not even close. They actually solve two completely different problems. So in this explainer, we're going to cut right through all the confusion and show you exactly what each one does, why they're different, and most importantly, why you might actually end up needing both.
Look, when we're building with these models, we are constantly, and I mean constantly, caught between a rock and a hard place, right? On one side, you've got the slow, super expensive reality of inference. Every single token costs you time and money. But on the other side, you've got the frustratingly short memory of the models themselves, that dreaded, limited context window that makes them forget everything. And this is exactly where our two tools come into play. LMCache, it's purpose-built to tackle that first problem, speed and cost. And MemGPT, well, it's designed from the ground up to solve the second problem, intelligence and continuity. See? Two different solutions for two very, very different headaches. All right, first up, let's dive into LMCache. The best way to think about this is as the efficiency expert. You know, it's the performance tuner for your entire LLM stack. Its whole reason for being is just to make things faster and cheaper. That's it. So what is it actually doing under the hood? At its core, LMCache is all about saving and reusing the little intermediate computations that an LLM makes. Specifically, it's targeting something called the KV cache, which is kind of like the model's short-term working memory while it's generating text. By just not redoing work it's already done, it absolutely slashes your latency and GPU costs. Now, this analogy right here, this is the perfect way to get it instantly. Just like a CDN stores images so it can serve them up to you super fast, or how Redis caches database queries so you don't have to hit the database every time, LMCache caches LLM computations. It's a pure infrastructure-level optimization. It's brilliant. So how does it pull this off? Well, it's pretty simple, actually. LMCache is just watching for repetition. If it sees an identical chunk of text, like a big system prompt or a shared conversation history that it's already processed, it just skips all that expensive GPU work and serves the results straight from its cache. And you know what the best part is? It's completely invisible. Your application logic has no idea it's even there. It just feels faster. And this means LMCache just absolutely shines in certain situations. If you're running a chatbot serving thousands of users, you've got tons of overlapping conversation history. Perfect. If your app uses the exact same complicated system prompt for every single call, that's a huge caching opportunity. Basically, anywhere you have repetition at scale, LMCache can save you a bundle. Okay, let's shift gears completely. If LMCache is a speed booster, MemGPT is, well, it's a totally different beast. You should think of this one as an external brain, something engineered from the ground up to give an AI agent real, persistent, long-term memory. The main goal here is to just shatter the limits of that context window. MemGPT is a whole system that lets the LLM itself manage a memory hierarchy. The model gets to decide what it needs to keep in its immediate attention and what it can store away for later, which effectively creates a context that can just grow forever. And this analogy really nails the difference. We're not talking about a simple cache anymore, like with LMCache. This is like the virtual memory system in your computer's operating system. It's not just about going faster, it's about giving the AI a sophisticated cognitive architecture so it can actually manage information properly. So how does MemGPT think? This is what makes it so wild. It isn't automatic. The agent is actively making choices. It's looking at the conversation and literally asking itself things like, is this important enough to keep in my main context right now? Should I save this new fact to my long-term vector database? Wait, do I need to search my archives for that thing I learned last week? Memory management becomes a tool that the agent uses to reason. This whole active memory thing makes MemGPT perfect for a totally different class of problems. We're talking about a personal assistant that actually remembers your preferences from week to week, or an autonomous agent that can manage a complex project over several days without ever losing track of what it's supposed to be doing. Anytime your agent needs to learn, adapt, and evolve over time, yeah, that's a job for MemGPT. Okay, so we've established they solve different problems, but to really truly get why they aren't competitors, we need to look at where they actually operate, inside the AI application stack. This is where it all clicks. So let's build out the stack. At the very bottom, the foundation, you have layer 1, the LLM runtime. This is the engine room, right? This is where tokens get generated and where that low-level KV cache we talked about lives. Sitting right on top of that is layer 2, the context manager. This is the part that's responsible for just assembling the prompt for a single turn of conversation. And then, all the way at the very top, you've got layer 3, the agent logic. This is the control room, the brains of the operation, where all the high-level planning and tool use and goal setting happens. And this is the punchline. LMCache lives way down here in layer 1, optimizing the raw metal of the inference engine. Meanwhile, MemGP is living all the way up in layer 3, making high-level cognitive decisions. They don't compete because they don't even operate on the same floor of the building.
This table just drives the point home perfectly. Look at the difference. LMCache deals with short-lived, low-level token states. The agent has no idea it even exists. MemGPT, on the other hand, deals with long-term, high-level facts and summaries. The agent isn't just aware of it, it controls it. Retrieval is totally automatic for LMCache, but for MemGPT, it's a deliberate act of reasoning.
So let's get practical. Now that we know what they do and where they live, how do you decide which one to use, or maybe both, in a real-world production system? Let's make a playbook. Okay, here's your checklist for LLMcache. Is your main pain point latency and cost? Is your time to first token just way too slow? Do you serve tons of users and have lots of repeated prompts? If you're sitting there nodding yes to these, LLMcache is going to be a fantastic fit for you. And now for the MemGP checklist. Is your agent constantly forgetting key details from one session to the next? Is personalization a critical must-have feature for your product? Is that context window the main bottleneck that's holding your entire application back? If that sounds familiar, you need an agent memory system like MemGP. But here it is. Here's the real pro tip. The key takeaway for building truly robust AI systems: you don't choose one. In production, you use both. Think of it like this. MemGPT is the smart strategist deciding what information is important enough to remember, while LMCache is the hyper-efficient engine, making sure every single one of those decisions is executed as quickly and as cheaply as humanly possible. They are a perfect team. We've covered a lot of ground here, so let's just boil this whole explainer down to 2 simple, powerful mantras that you can take with you. For LMCache, the mantra is simple: don't recompute what we already know. It is all about pure, raw efficiency. For MemGP, the mantra is decide what is worth remembering. It's about strategic, cognitive intelligence. You see? One is about saving compute cycles, the other is about saving thoughts. And all of this leaves us with one last, big question to chew on. As these agents get more and more complex, are we actually witnessing the birth of a brand new, dedicated memory stack in AI architecture? You know, a whole layer where cognitive systems like MemGPT and efficiency engines like LMCache work together seamlessly? It's definitely something to think about.